Hi everyone, welcome back. So in this video, we are going to be discussing some more important points regarding our data types. So I hope you guys remember in the previous video, we already saw some topics like what is a data type, what is the role of a data type in a programming language. Okay, and based on the data type concept, how can we classify the programming language? Then more specifically, we also discussed about the different data types that are available in our C language. So all these things we already covered in our previous video. So as a continuation to that, okay, we will be discussing some more in-depth and important points regarding our primitive data types. So as we already said, first we should have a complete knowledge about our primitive data types, and then only we can move to the other categories. Right. So the first thing what we should be knowing is about our first data type, which is nothing but int. Int is probably one of the most commonly used data type what we have. And we already know int is used to store whole numbers. That is full numbers without any fractional or decimal values. Right. And what is the important point that we should know regarding our int is the memory allocated to the int data type depends on the system's configuration. So in this, there is one very important point we should be knowing. C language is a mission dependent programming language. That is, there are some things, some points that you have to remember, and I will also be telling you in our upcoming videos. That is, the output of some important things depends on our system. So one such thing is my int data type. Depending on my system's configuration, the memory allocated to my int actually differs. So if my system, if my system is a 32-bit system, then integer occupies only 2 bytes of memory. So how much of bytes will be allocated for my integer is 2 bytes. That is 16-bit. If my system is a 64-bit system, then integer will get 4 bytes of memory allocated for it. That is 32 bits. So depending on the system configuration, the memory that is going to get allocated for the integer data type actually differs. This is one of the first point what you should be knowing regarding this particular data type. Now, the next important point is how the numbers can be stored. So I already told you integer means whole numbers. So how the numbers can be stored is based on two categories. We have something called as signed and unsigned integers. That is the keyword int. We can use it as a signed integer or as an unsigned integer. Now, what is this signed and what is this unsigned? So signed integer means inside that data type, inside that variable, you can store both positive as well as negative numbers. That is, when I'm creating a variable of the int category. Okay, if I am creating that variable as a signed int, then the variable has the capacity to hold both positive numbers as well as negative numbers. Now, same thing, if I am creating the int, if I am going to create the int data type as an unsigned category, as unsigned integer, okay, then I can store only positive numbers. Negative numbers is not possible. Negative numbers is not possible. This is what you mean by the two categories of the integers. So there is one category of integers which can store any type of numbers. That is, whether the number is a positive number or whether it is a negative number. It can hold both the type of value. And the second category is integers that can store only positive numbers. Now, I hope you guys remember, I told you in our previous video itself that every data type, every data type is having a memory. That is how much of memory is going to get allocated for that data type. We have a fixed memory. Now, depending on the memory, depending on the memory allocated for the data type, we have a range of value that can be stored inside of that data type. Suppose I am creating an integer. I am creating a variable, say int a, or I'm very specifically saying signed int a. That is a variable A which can hold both positive and negative numbers. So what is the minimum capacity and what is the maximum capacity that variable can hold? So we have a formula to calculate that. So please understand, every data type, it has a capacity, it has a range. That is how much of value the variable can hold. And this range depends on the data type, because based on the data type only, memory space is going to get allocated. So for that, we have a formula. So the minimum and maximum value my signed integer can hold is calculated based on this formula. 2 to the power n minus 1 is the minimum value. 2 to the power n minus 1 is the maximum value. So I have a minimum value and I have a maximum value. How to calculate this? Using this formula. If it is an unsigned integer, that means what? No negative value, only positive value. Then how to calculate? For that also I have a formula. So only positive numbers means what? From 0 only it can start. So 0 to up to what? What is the maximum value? Minimum value is always going to be 0. Right. So what is the maximum capacity? Is calculated by the formula 2 to the power n minus 1. Right. So this is how I will have to find out the minimum and the maximum value. So all we have to do is remember the formula. Right. Now, let us say an example here. Now, we are using n minus 1, n. What is this n? N is nothing but the number of bits that is allocated. Remember, I am not talking about bytes. I am talking about bits. So 1 byte is equal to 8 bits. So based on that, how many number of bits is getting allocated? Based on that only n value is represented. Right. So let us try to calculate and see. Let us see a small example. Now, in this example, I am going to consider int as 2 bytes. Let us assume my system is a 32-bit system. So integer, whenever I create an integer variable, it is going to occupy only 2 bytes of data. So 2 bytes of data means what? 16-bit. I told you 1 byte is equal to 8-bit. So that means 2 bytes is 16-bit. So my n value is going to be 16. Now, what is the formula I told you? Signed int. That is an integer which can accept both positive and negative numbers. So this is the minimum value. 2, this is the maximum value. So 2 to the power 16 minus 1. Why? Because n value is 16. 2 to the power 16 minus 1 minus 1. So apply the formula. Substitute the values. So 2 to the power 15. This is the number you're going to get. Same way, 2 to the power 15, then whatever the value, minus 1. So this is the range. Minimum value, maximum value that a 2 bytes integer can hold. So if I am going to create an integer integer variable or in a 32-bit system, then this is the capacity. This is the minimum capacity. This is the maximum capacity the variable can store. Same way, let us consider unsigned. What did I say unsigned? Only positive numbers. Say same 32-bit system, unsigned integer. So again, 2 bytes, 16 bits. So what is the formula? 2 to the power n minus 1. So 2 to the power n, 2 to the power 16. Okay, 2 to the power 16, this is the value you're going to get. So minus 1. So I told you, minimum value is going to be 0. Why? Because no negative numbers. So it is always going to start with 0. What is the maximum value? That is what you have calculated here. So 65536 minus 1. So 65535. This is our maximum value that a integer can hold in a 32-bit system where it occupies 2 bytes of memory. So like this, you can calculate the range. See, it is not possible for us to remember these numbers. So for each and every data type, we have the range. The number is already calculated and given. But it's not humanly possible for us to remember all the range. So it is always better if we can remember the formula anywhere asked, we can directly calculate the range. Right, so this is now applicable for even the char data type, even our short int, long int. everything, the formula is going to be same. For unsigned integer, this is the formula. For signed integer, this is the formula. So that is not going to change at all. Okay, you just have to calculate what type of, how many bytes is allocated. Based on that, the n value is going to differ for us. Right, so these are the important points you should be knowing with regards to our int data type. Right, now the next one is, of course, we have the char. And we already know char, single character or a group of characters. In our previous introduction itself, we discussed the char is our data type. It can be used in two ways. One, it is used to store a single character, or it can be used to store a group of characters. That is nothing but our strings. For both of this, we use the same data type called as char. So again, char was what? Characters. So what are the characters? Alphabets, digits, special symbols. Everything together is what we call as a character. Right. An example. For a single character, how we are going to say char followed by the variable name equals to enclose the single character within single quotes. Enclose the single character within single quotation and then semicolon to end the statement. If it is multiple characters, that is if it is a string, again, how we are going to use it? Same char data type followed by the variable name. But what is the special syntax we use here? Within the square brackets, we have to mention the number of characters. Maximum number of characters. I'm saying this is the maximum capacity my variable can store. So 50 characters. So you're saying maximum is 50. In that, you can give 0 to 50. Any number of characters you can give, specify here. So since you are creating the size as 50, it is not necessary that you have to give all 50 characters. So you're saying maximum value is 50. Right. And we know char data type occupies 1 byte. In the system, it occupies 1 byte of memory. So for gender, it is going to occupy only 1 byte. But for this string, how is the size calculated? Based on every character. I'm saying one character means 1 byte. What is that I'm saying here? Maximum is 50 characters. So how many bytes of memory? 50 bytes of memory will get allocated. So please remember, when I say char and I'm giving the variable name and I'm storing a single character, it is going to occupy 1 byte. But when I'm planning to give a group of characters, how is the size calculated? Based on the maximum number of characters you are specifying. This much of bytes will get allocated for the variable. So this is how the memory is going to get allocated for the char. And char is fixed. Only for the int, the memory will differ. According to the system configuration, only for the int data type, the memory will differ. For all the other remaining data type, the memory is fixed, standard. Okay, for whatever is your system configuration, if it is 16-bit, 32-bit, 64-bit, whatever it is, the other data types all have standard memory allocation. Right. Now, one more important point. From the time of invention of our computers till today, computers can understand only zeros and ones. We all know that computer can understand only zeros and ones. It is not possible for us to write the program in zeros and ones. So obviously we use our high-level programming language. Then we use our converters to convert the program. Right. So now when I am going to give a character like this, say I am saying this variable name is gender, I am storing the character F, or I'm going to store the character hash symbol or dollar symbol or at the rate of symbol inside that variable. How will my compiler understand that? How is my compiler going to understand a dollar sign as a value? So for that only, we follow the concept of encoding. We follow the concept of encoding. That is, whatever the characters we are giving, we have to convert that into numbers. Again, we means we are not going to do it. Our compilers is going to take care of that. But to convert, it has to follow some standard. It has to follow a specific pattern. That pattern, what my compiler uses is the two encoding formats. two encoding formats are available for my compiler to make use of. One is what we call as ASCII values, American Standard Code for Information Interchange. So that is what we call as an ASCII. That is, in ASCII, there are totally 128 characters. 128 characters are present. That is, for example, our keyboard. Each and every character present in our keyboard will have an equivalent number value. Equivalent number representation is available for all the characters in our keyboard. That is what we call as ASCII value. That is for capital A, for small a, for at the rate of, for the numbers, for the space, for the enter button, for the function button, for each and every key. We have an equivalent number representation, and that is what we call as an ASCII. So totally there are 128 ASCII characters. Now, I told you there is another format which is called as ANSI, American National Standard Institute. What is this? This is a next level to our ASCII. ASCII has only 128 characters. So in ANSI, we have 256 characters. See, normal English, okay, fine. But there are keyboards which have other languages also. So you need to have the Unicode support for everything. So ANSI follows that standard. That is the first 228 characters belong to the ASCII. Whatever is there in ASCII, that the same thing is available in ANSI also. Apart from that, all other characters are also added to it. Okay, these are the two encoding formats that my compiler is going to make use of, especially when it is going to work on the char data type. For example, look at this. I am creating a string value. I am saying char name. Name is name of my variable equals to ANU. Anu. I'm giving the value as Anu. Right. Now, what will my compiler know about? What will my computer understand about A? Nothing. It doesn't know what is A, what is N, what is U. No idea about it. But what will happen in the background? So the A has an equivalent ASCII number, 65. So if I have a number, possible for me to convert it into zeros and ones. That is my binary. Yes, that is what is going to happen. So N has an equivalent ASCII value. U has an equivalent ASCII value. So each and every character present has an equivalent ASCII number. So the compiler will take this ASCII number and then it will convert it into binary, and then internally it is going to get stored inside my memory. So even though you're creating a string like this, internally inside the memory, it will be stored like this only in form of zeros and ones, because this is what ultimately my computer can understand. So please remember, whenever you're dealing with your char data type, okay, the concept of your ASCII and ANSI is very, very important. It is what we call as encoding. The encoding formats, what we are going to be making use of. Again, I'm telling you, it is for knowledge sake. As a programmer, you are not going to do this encoding. The compiler is going to take care of it, but you should know what is happening in the background. Right. Okay. Now, relationship between the char and the int data types. This is what I keep telling you. Equivalent number representation because of the ASCII values. Now, have a look at this program. I am asking the user to enter a single character and I am storing it inside A. Look what type of variable is A. A is a char variable. So single character from the user, store it inside A. Now, I am using format specifier %C. %C will print the value of A. That is as a character. Whatever character I have got, I am just printing the character. Okay, fine, no problem. But look at the second print statement here. I am saying %C and I am also using %D. I am using both the format specifier. We know %C represents char and %D represents integers. That is decimal numbers, whole numbers. Now, look at the variable list I have given. A, A. Both are same variable. Both are char variable. So, I am printing the value of A using percentage C also, using percentage D also. So what is going to happen here? When I use percentage C, it is going to print the character. When I use percentage D on a char data type, it is going to print me the ASCII value of that character. So this is the relationship between the char and my integer. So please remember, when I'm using percentage D, it will print a character. When I'm using percentage D on a char data type, it is going to print the ASCII equivalent value of that particular character. Right, so let us try to run it in a program. Now let us go and try to take it in a program. I'm just going to copy this piece of code. Okay, there you go. I'm going to run this. See what is happening? It is asking me to enter a single character. Right, okay, now I am typing at the rate of. Now you see what happens. So the single character value is what? At the rate of. Now look what is coming. ASCII value of at the rate of is 64. How it is printing me the 64? Because I am putting it as percentage D. So whatever is the character, equivalent ASCII value will be returned when I am using the percentage D on the char data type. Now let me run this again. Okay, this time I'm going to give an alphabet. I am saying capital A. So ASCII value of capital A, 65. See, now run this again. This time give small a. I'm saying small a. Now look here. 97. Right, so see how it is going to print the values. Right, now run this again. This time give a number. I'm saying number 5. See, every character on my keyboard has an equivalent ASCII representation for it. So that is what is very, very important for us to understand. I have given here a space. Space is not visible to our eyes. But see what ASCII value I'm getting, 32. This is what I told you. Each and every character present has an equivalent ASCII number. So how to print the ASCII number? Simple. Make use of the percentage D format specifier on the char data type. Right. So this is the important things with regards to our char data type, what you should be knowing. Right. The third category is our floating point data type, or what we call as real numbers. That is numbers with a fractional or a decimal value. Salary, marks, all these things may have a fractional value also. I can say my percentage is 82.5, 82.3. So with some fractional or decimal values. For that only, I have the floating point, or what we call as the real numbers. So totally 3 things are available, right? Float, double, long double. Remember our video on modifiers, right? We saw concept of our modifiers where I told you what is the long means. Long is one of the modifiers which is used to increase the memory capacity. So whenever you are going to create a variable of the float data type, it will occupy 4 bytes of memory. When I am going to create a variable of the double data type, it is going to occupy 8 bytes of memory. Same thing, when I am going to create a variable of the long double, it is going to occupy 16 bytes of memory, 16 bytes of memory. Okay, so all these 3 data types are used to store same type of value, that is fractional or decimal values. But what is the difference? The capacity, the range, how much numbers it can hold. The range is what is different. Why is the range different? Because data type memory allocation. So float 4 bytes, double 8 bytes, and long double 16 bytes of memory will be allocated. Right, so for floating point, we call it as a single precision, and it can represent up to 7 digits of our numbers. So when I talk about double, as the name suggests, double precision, it can hold up to 16 digits of numbers. So when I talk about a long double, okay, long double, up to 90 or 21 digits. Even in some compilers, up to 21 digits of numbers, long double have the capacity to store. So based on how you want to store the values, you can decide which data type is suitable. Okay, which data type is suitable, you can decide according to our program's requirement. Right, so this is about our float. Now, look at this simple example. Here, we are going to discuss the relationship between a float and an integer. We already know integer, whole numbers, float, floating point, that is my decimal values. Now, look at all these three calculations. I have variable v1, v2, v3. So, all these three variables are going to hold the result of an operation. It's going to hold the result of an operation. What operation I'm doing here? Division. I am going to perform a division operation and the result of it is going to be stored inside a variable. Right, first time v1. v1 is an integer variable. So how you are creating? v1 as an integer variable. Right, now 4 divided by 5. 4 divided by 5. So please remember numerator, denominator. The denominator is bigger than my numerator. So definitely it is going to give me some value in 0 point something something. But what is the problem? 4 divided by 5, both the numbers are what kind of a number? Integers, whole numbers. Okay, so the result of the division operation also will be an integer. So please remember this very carefully. Why am I creating v1 as an integer? Because 4 and 5, the two numbers, the numerator and the denominator, both are integers. Hence, the result of this division operation also will be an int value. Int value means what? Only whole numbers. It does not support any fractional values. So that is why I am creating v1 as an integer. So the result of this v1 is going to be 0. See, normal operation will produce 0 point something, but since it is integers, it is going to give me only the whole number. What is the whole number? 0. That is what is going to get stored inside v1. Now, look at the second one. In the second one, I am creating v2. But v2 is what data type? It is a float data type. That is, it has the capacity to hold decimal values, fractional values. Now, what is that I am dividing? 4 divided by 5, same. Again, remember, even though I am trying to store the result in a floating point variable, both 4 and 5 are what type of value? Integers. So the result of the operation also will be only an integer. How can I store an integer inside a float? Not possible. So please remember that very carefully. Just by creating v2 as a float and storing the value will not be possible. Why? Because 4 divided by 5, what we are doing is an integer operation. The result is going to be an integer. So even though we are going to store it inside of a float, it will not be acceptable. The result is going to be something like 0.0000 like that, up to 6 digits. After the decimal dot, 6 zeros will be coming. It will not take the value at all. Now, look at the third variation I'm doing. 4.0 divided by 5.0. Now, this is a real number. This is a real number. So, obviously, the result also will be a real number. So, now, yes, if you're going to store it inside a float, possible. Right, so please remember that the result of any expression will be based on the data type. It's going to be based on the data type. We have to create the appropriate data type and then store the value inside. Right, so let us try to execute this program also. There you go. I'm just going to copy this code. Yes. See what is that happening? Just as we predicted. First thing is 0. Second thing is 0 point. After the decimal dot, 6 zeros. Right, and the third one. Since it is a floating point value, that is a real number, Result is also a real number. So V3 is the correct format. So it is showing 0.8. Now, remember I already told you one thing. If you want to print only a couple of decimal points after the dot, I want only one decimal, I want only two numbers, then you can give it like this. What do you say? Percentage, then a dot. After the dot, how many values needs to be printed? You are going to specify the number of digits and then you will give the F. Now, run this. Look what it is showing. 0.8, only one digit is getting printed. Now, you say here 0.2F. Now you run this. That means after the decimal dot, two digits. See, 0.80. So like that, you can, how many digits you want, you can restrict that and print it. It will do a round off operation and it is going to print the result up to that specified decimal digits. Right. Then, of course, we have the data type void. Void. So void means nothing. Void data type means no value, nothing. Normally, we use the void data type in two situations. One, when we are dealing with the concept of functions. You remember, functions is one of our derived data types. So what we are discussing is our fundamental data type. Void is one keyword, one data type, which is of fundamental, but we use it for creating our functions. We use this word with the concept of our functions. That is one thing. Second thing is, we also make use of the void data type or the void keyword along with the concept of pointers. I already told you we have one concept which is very, very important in our C language called as our pointers. That is address manipulation. Pointers is simple, but address manipulations. So there again, I will be making use of this void keyword. Right. So these are all the important points what we should be knowing with regards to our fundamental data types. Right. There are a couple of more points which we will continue in our next video. Right. Thank you.